Hello, in this video, I will walk you through my time series forecasting and data visualization project. This project aims to analyze power consumption data applicable to a particular equipment for a particular location in a particular year. And we will also visualize patterns that offer deep insights into power usage. Beginning with data preprocessing and feature extraction. The first step of the project involved data preprocessing using custom Python functions. Let me summarize the key parts. Filling missing data. I utilized a function to ensure no gaps in the dataset by filling missing ones with zero values. This is critical for the accuracy of forecasting models. Next is feature calculation. I extracted monthly and total power consumption for specific equipment and location. Additionally, I computed the average temperature for each month, which is an important factor influencing the power usage. For instance, I used functions like calculate monthly means for a particular location, equipment, and a year, and calculate monthly means for, for aggregating the data effectively. Next, coming to the visualization parts. I used custom built plotting utilities from my plotting utilities.py file to generate these graphs. These visualizations helped identify trends such as how certain months showed peaks in power consumption due to the temperature changes. Here are some of the functions that I used to create charts. It also includes a dual axis time series plot. Next, let's come to the time series forecasting part. A key part of the project was breaking down the time series data into its core components, the trend, seasonality, and the residual part. This is, as you can see in this screen, this is a graph for a power consumption versus hours for over 7 days over a location, France, and for equipment air conditioner. I visualize these components, namely trend, residual, and seasonal, for the power usage of air conditioning in France for a month of April. This decomposition helps reveal hidden patterns that are essential for effective forecasting. Now, the next step was to predict future power consumption using S-ARIMA model and ARIMA model. I used Auto-ARIMA library from the PMD ARIMA to get the hyperparameters required for the ARIMA model. Now, for training the model, I trained the S-ARIMA model on historical data considering seasonal variations and trends. I also plotted the PSEF and ACF plot to get the values of P, D, and Q required for ARIMA model. Now, the actual versus predicted power consumption graph looks like this. Now, to visualize the results of the S-ARIMA model, I plotted the actual and forecasted power usage, showing how closely the model predictions align with the real data. Additionally, I visualized hourly power usage over 7 days to provide a detailed breakdown of consumption patterns. The result that we get by using Auto-ARIMA forecast was something like this. Whereas, if we applied S-ARIMA model by including the PDQ values as 000 and capital PDQ values as 210, we get the predictions such as something like this. Now, in conclusion, this project provides a full cycle from data preprocessing and visualization to time series forecasting. The insights derived from this analysis, particularly through visualizations and the S-ARIMA model, are crucial for optimizing energy consumption and future planning. Thank you for watching. I hope this gave you a clear understanding of my project.